Evening, sir.
Hi guys, how are you? Hey JJ, how are you doing?
Sir, my first yo. My first yo.
Well, actually, no, I was here alone on two
No,
occasions,
sir.
but no, seriously, man. But guess what? No, I was here alone, but it keeps kicking me out. I don't know what is happening. So when I locked down, I was the only one here on two occasions, and and then I walked to another location, and then I'm able to get on. But I'm happier here safely. Um. As for the others, hey, Amanda, can I put your last name on the thing for me, Amanda? Thank you for record purposes.
Hi, sir. Can I ask you a question?
Absolutely.
Right. I wasn't here for the last session. When will you be displaying? When will we be getting our grade?
All right. Somebody will answer it in the chat about that for
All
me.
right.
Cool, no problem.
Mhm.
I love you, Jesus. Lord, I love you more than anything. Worship and adore, so to tell, worship and adore, so to tell. All right, guys. As you know, I normally give you 15 minutes grace period, but these 15 minutes showing only 11 of you. Um, can you make contact with the other classmates for me, please?
Sure, sir.
Thank you. I want to move, and the content that I'm going to be teaching now, I don't intend to reteach, so I'll just give another. So I'll give another 10 minutes. It's just 5:17. I give another 10 minutes. All right. Thanks. All right. It appears that this is what we'll have to work with. And I'm good with that. Just to let those of our other classmates know that I will give a 15 minutes grace period, but we have to get going. All right. I am I'm having some difficulties, some technical difficulties, but I will go as far as the devices will lend me. I know we meet tomorrow again, so just bear on with me. Just checking, are you all hearing me?
Yes, sir.
All right, good. Thanks. Um, Maybe because I don't use these things for quite a while, it is giving me some issues. All right, so um
Very lucky.
right. All right, so I had a conversation with you last class. Um, the diagram that I had last time around not coming up. Um, Part of the technical difficulties that I'm experiencing. But if you can think back to what we discussed the last time around on Tuesday, I will then take the conversation a little bit further. I did promise you though that I was gonna go through, but this is giving me hell. I was gonna go through this once more. So bear on with me. I will attempt to draw something. All right, so let us try this now. So what I'm doing here, I'm taking my initial guess. I'm call this f of x1. I'm guessing f of x1 there. So I'm going to pull down all the way down. This is going to be my x1. Then what I'm going to do here, I'm going to draw a tangent to the curve where it meets the x-axis. I'm going to call that my x2, which would be my second iteration, f of x2. Similarly, drawing a tangent, wherever that tangent hits here, that's my x3, my f of x3. Wherever that tangent hits here, that's my exact solution. So this is what the iteration is talking about. I'm guessing, I'm making an intelligent guess at the start, and then I'm going to continue with that guess all the way down until I have arrived at my desired solution. Until I arrive at my desired solution. Now, one of the things that I want to remember, they made an update to this Zoom something, the interface is different, is this one here will be my y2, my y1. I have my x1 and my x2 already. So I'm calculating the slope here. So I'm calculating this slope. And that slope is going to be equals to my rise over my run, which is the same thing as my y2 minus y1 over x2 minus x1. Give me another name for slope. What's another name for slope?
A curve, sir.
Another name for slope. I can speak of the slope or the slope is what?
The tangent.
Is it like
Huh?
gradient, sir?
Okay, so the slope is a gradient. And when I calculate the gradient, what am I finding?
It should be y equals mx plus c or something like that.
Yeah, so that's what the slope is. So the slope is going to be y equals mx plus c. That's a gradient. But give me another name for gradient now. Not slope. Don't give me slope and be smart. When I'm calculating the gradient, what am I doing?
I calculate this. Another name for slope again, sir?
Mm-hmm. The big people name now. When I look at the change in x, the change in y over the change in x, what am I doing?
So is that finding the derivative?
Very good. Very good. So I'm calculating the derivative, which is really the change in y over the change in x. The change in y over the change in x, and this is why we have dy by dx. So dy by dx is really the change in y over the change in x. The change in y over the change in x. All right? So I did this on Monday, on Tuesday. Promised you that I was going to do it over. Here it goes again. So now it is that I'm going to apply a question on Newton-Raphson. How many of you got an opportunity to watch any of the videos on Newton-Raphson? Did anybody?
Can you repeat that?
Did you get an opportunity to watch any video on Newton-Raphson?
No, sir.
Okay. That's fine. So I'm going to give the formulation now. So my formulation is going to be x n plus 1 is x subscript n minus f of n over f dash x n. So that f dash is my derivative. That f dash is my derivative. All right? So x to the sub, so if n is 1, think about it. If n is 1, 1 plus 1 is equals to what? All right. Clearly, you guys are not alert. You guys aren't ready for class tonight. Let me know what is happening.
Sir, what there, man?
But may I ask
Basic
question? Nobody
question you
not ask.
ask, sir. 1 plus 1,
Yes.
2, sir.
Yes, man. So answer me, man. Sure. So this is going to be x subscript 2. Remember, n is 1. So this is going to be x to the first minus f of x to the 1 over f dash of x to the first. So what I'm saying to you, if I'm finding the second iteration, I must use the first iteration minus f of the first iteration over f dash of the first iteration. Whatever I get right there, that is going to be my second iteration. To find the second iteration, I'm going to use to find the third iteration, sorry, I'm going to use the second iteration. To find the fourth iteration, I'm going to use the third iteration. You get the gist of it?
Yes, sir.
All right,
Yes,
In
cool.
order, sir. You have to do one first before you can do the other.
Before you can do the other. Excellent. One must be done first before you do the other one. All right. Let's go. Let me generate a question. Mm. All right, let me just give it a function instead of generating the thing. F of x is equals to, say, x cubed minus 4x squared plus 1. All right, now, you're given a function, f of x is equals to x cubed minus 4x squared plus 1. I need to find a solution to this function using Newton-Raphson. And I want to pay attention carefully. Using Newton-Raphson. Now, how do I make a guess for my initial iteration? Where am I going to start? I don't know. It wasn't given to me. So I need to go and find it. So what I'm going to do, in trying to find it, I'm going to say let x equals 0. That gives me 0 cubed minus 4 times 0 squared plus 1 And that is equals to 1.
1.
Let me try now. X equals 1. 1 cube minus 4 times 1 squared plus 1. That is equals to -2. And also 1 plus 1 is 2. 2 minus 4, 2. Agreed? Disagree?
What answer? Yes, sir, agree.
So hear me now. Going back to what I did on Tuesday. The mere fact that my substituting x equals 0 in the function and x equals 1 gave me one of the answers to be positive and the other answer negative. It tells me that the function has crossed the x-axis. Remember I told you up front, it has to cross the x-axis in order to give us the exact solution. You know, answer me no, man.
Yes,
Yes, sir.
sir. Yes, sir.
So that's exactly what is happening here. So I know I have -1, I have +1 and -2. So I know that one sign is positive and the other sign is negative. So I know that there's some crossing of some axis in order to get that to that. All right? I have +1 because remember f of x is y, you know. So I know that it crosses the axis. So what I can safely say is that the solution or the root, one of the roots of this equation is going to lie between 0 and 1. It may be 0.25, it may be 0.785, it may be whatever it is. But I know my answer is going to be lying between 0 and 1. Sir, how you know that? Because when I substitute 0 into the function, I get a positive number. It doesn't necessarily have to be +1. I get a positive number. But when I substitute a successive number following that, which is 1, I'm getting a negative number. So my output, my dependent variable is now giving me one root being positive and the other root being negative. So therefore, I know that that is one of my solutions. Then, sir, what if when I substituted 0, I got it to be positive, and when I substituted 1, it was positive? It means that there is no root between there. Okay, so I substitute 0, sir, and I got it to be positive. I substitute 1, I got it to be positive. But when I substitute 2, sir, I got it to be negative. It means that the root lies between which two numbers?
Sir, repeat
0
that.
and 2.
All right, press pause. Press pause. Oh, no, me check phone, you know. That is the truth. I don't know this too. Make we have a deal. If you don't want to have the session tonight, respectfully say, sir, work just done. We're tired. Can we pick up tomorrow? I have no problems. What I don't want and I don't appreciate is for me to expel my energies and then not pay me attention and then not learn. Real talk. I'm not gonna feel no way, honestly.
Sir,
But I
I want
prefer
you to continue, but I honestly don't understand. I'm a bit
it.
lost, so I'm just trying to catch on.
Okay. I appreciate that. All right. What about the rest of you? Because I've been asking questions and there is a delay in responding, and I have to be stopping and asking to answer. So, what I say?
Sir, I'm a little lost too.
Okay. So there are only 2 students in the class.
No,
No,
sir.
sir.
Yeah, man, we're there, sir. We're there. We're there. We're trying to make sense out of it, sir. Nah, like,
Mhm. It's not a good start to the calculus 2. The calculus 2 is more difficult than calculus 1. Calculus 2 is under the impression that you would have mastered calculus 1. Now it is that we're going to be doing the applications. We're now doing the applications to what we did in calculus 1. So I'm going to start again. I'm going to ask in Jesus' name just to be a little bit alert and work with me. So I'm not going to go through that diagram again. I'm not going through that diagram again. What I will do, however, I have given you a formulation, something that I'm expecting you to know. Newton-Raphson. All right? Now, when I went through the diagram was to explain how the formulation came about. I'm going to take it that you understand that. I'm not going through that. What I was explaining to the right of that one is to say, if I have my x1 and I'm trying to find x2, I'm going to be substituting my x1 into the formulation. That gives me my x2. If I'm trying to find x3, I'm going to substitute into my formulation the value of x2, and so forth and so on. Then I move into an example. X cubed minus 4x squared plus 1. What I'm saying to you is, I was not given my first iteration. I don't know what that one is. I was not given it. So what I want to do now is, I'm trying to guess what the first iteration is going to be. I'm trying to guess what the first iteration is going to be. And guessing what the first iteration is going to be, what I'm going to do is, I'm going to start, say, for example, x equals 0. When I substitute x equals 0 into the function, I'm going to get x equals positive 1. Do you see that? Do you agree with that?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, fabulous. Secondly, I'm moving on to the next consecutive number. My x equals 1. My x equals 1. My x equals 1. Again, I'm substituting it into the
question,
set
sir.
equation. Go ahead.
So you guess the x equals 0 and you get positive 1 as your answer. Is that positive 1 your second guess for x equal positive 1 for the equation below?
When you say second, guess what you mean?
Never hear you, sir. Repeat that. Go again, sir.
When you say second, guess what you mean?
No, not second guess. So the answer that you got for the first function, right? I'm asking if that is the answer that you plot into x for substituting x equal 1 for the second function.
Right. Hold on there now. Hold on there, puppy. Hold on there. My loss. Ask me the question one more time, Nigel.
No, man, what I'm going to say is the answer we get for function number 1, is that the same positive 1 you have substituting as x for the second function?
No, it's a different one.
Okay.
That's why I said consecutive substitution. So that's what I'm saying. So I start with x equals 0. It doesn't matter what value I get out there. It so happened that I get a 1 outside there. Right? But I need to move to the second consecutive number. And the second consecutive number now is going to be 1, having you 0. So that's why I'm substituting that one. So the two ones that you're seeing there is not the same ones.
Yeah, sir. Get it now.
Okay, good.
Hi.
So, hello, Mario. And then now, I'm going to substitute that x equals 1. It's a different one, not the same one, into the function. Now, when I substituted that one into the function, I'm getting a negative 2 coming out. So what I'm saying to you, the mere fact that I'm getting one result, the output to be positive and the other output to be negative, it is suggesting that I would have crossed the x-axis, suggesting that I would have the root of my one of the roots of my equation. And I'm saying one of the roots. How many roots this equation has?
2 so far, sir.
How many roots in total it has?
Sir, I'm a little confused by what you mean by roots.
How many solutions it has?
Isn't it just one, sir?
So I'm still saying.
When not click at heart tonight, no,
Sir,
sir.
me just
Wait,
join.
isn't there just
Sir, is
one
it 3?
solution, sir? One root.
3?
It has 3 roots. Why does it have 3 roots?
Sir, the diagram,
3 different points.
The order of the polynomial is 3. Sir, what is the order of the polynomial? The highest power in the polynomial. Only cancel in all this, innit? Only cancel in all this.
Sir, we're still looking at the Nord. When name Newton's Raphson law. Whatever it is.
Right, yeah.
Sir,
So,
sorry for the late join.
yeah, man, no problem. So let's go again. It has 3 solutions, 3 roots. I'm trying to find one of the roots. Wow. Do me a favor. Give me about 5 minutes, please. And I'm being strategic in these 5 minutes. I want you to walk around, all of you. Moya, just come in, go drink a cup of water, do something, and regroup and come back. All of you. I don't like what is happening. You guys are not clicking, and it's not that you don't know what to do. I know, only know, because you know why? I'm me the teacher in the calculus 1. So I no. So take a few, and then we're going to come back again.
All right.
Okay, guys, I apologize. I got disconnected. I told you that I'm having some issues. Um,
Yes, sir.
yeah, man, I lost my, we call it now, whiteboard. Let me just see if I can, um, existing whiteboard. All right, so I lost it. So maybe it's a good time for me to jump. Does anyone remember the the function that I gave?
Yes, sir.
Please, before this,
F of X
just wait until it comes out.
more than my writing.
Hold on. Oh, Lord. It's a smell. Hey, Miss Maya, and Chevy too, it. I'm not
No,
born.
no, sir. Chevy a frame wire.
I'm not born. Let's go from JJ. All right, so go again for me, please. What's the function?
Sir, F of X is equal to
Mm-hmm.
X cube
Mm-hmm.
minus 4X squared plus 1.
Second me, that's correct.
So is that is that f of n or f of x, sir?
F of X is just that's how the Americans write it.
That's crazy.
Now gonna make us tell me in 2026, you know. They tell me enough in 2025.
Stylings.
And then now tell me in
Sir,
26.
sir, is that a 2 or a E, sir? I'm quite confused with the writing.
That's why you did not went to school tonight, you know. You shall eat your dinner, you shall be hungry after you eat.
Sir, you shall be hungry as well. You
No,
know,
but me
that's
eat
it
my
what we
dinner
do.
already. No, but me eat my
You
dinner already,
know,
my
that's it
belly
what we
full.
do, sir.
All right, so it is x cubed minus 4x squared plus 1.
Sir, not even no film on or bad writing.
Okay, tonight is speak for my night. All right, and enjoy. Enjoy.
More
Sir,
All right, let's
than
go.
at the equal sign him attack, it look like E.
Oh, that. Then you need to be more specific, sir.
But you're supposed to pick up on your writing if you think. Anyways, sir,
That's
we can pronounce the name of the something again. Newton's what?
Rapson.
Rapson.
Right. Newton Rapson.
Sound like
Let's
one
go.
letter in the
Anybody remember the
silent.
form? The PH with the F sound.
Oh, or Raf. I think it's a
Right.
Rapson. All
No,
right.
Rapson. All right, let's go now. Anybody remembers the formulation? What's the formulation? X n plus 1 is equal to
xn minus
over f dash of x subscript.
yes, sir.
Good job. Remember that and you're good to go. Remember that and you are good to go.
sir, and N represents what again? Is it the
The number of
same like the?
iteration,
Okay.
the number of iterations. N represents the number of iterations. You heard me?
Yes, sir.
What was that over? Let's go for it. Right. N
Sir, not
represents the
hear me.
number of I don't know. I don't know. Tonight is just an off night.
I'm hearing you, sir. We're hearing you
We're
clearly.
hearing you, sir, yeah.
Oh, okay.
Yeah,
Because
we're hearing you.
I just heard something like something was going to go dead a while ago. Anyhow, so right. So N represents the number of iterations, and they have x to the n plus one is going to be equal to x to the n minus f of x to the n all over f dash of x to the n. So what I'm saying to you is we're oh Lord. All right. All right. Guys, sorry, I need to sort out something because I'm not hearing it. All right. Give me a minute, please. I'll come in. I'll come in.
All right,
I'm going to sort
sir.
out something. Cool.
Sir, are you speaking?
No.
Sir. Sir, 0.125.
Sir, me go try for myself cause me think me understand but me don't know what going but me go try to see if I understand what's happening and how they arrive at one thing. Sir, I don't know if you can hear me, but if you can just respond with a thumbs up to this question or thumbs down.
No, I can hear you, but you're saying that you wanted to check to see if the 0.125, if that is correct from your part. Did you get the 0.125?
Right, so I'm checking that now. So my question is, sir, each iteration we start we start the index is 0, so we start from 0 at all times, and then we proceed with the iteration. Because it's like
I'm gonna say yes for no. Yes.
okay.
I'm gonna say yes for no. All right. So I can erase this. I can erase this question that I asked if agreed, and I really hope that everybody else is following. I only wrote
Yes,
back what
sir.
No,
it
sir.
is. Okay,
Sir,
fabulous,
hold on.
fabulous. All
Sir,
right. So
no,
get.
don't
Go ahead. Sorry.
erase it.
No,
Sir, I
me
was
not
saying
erase
don't
nothing.
erase it.
I'm
Oh,
not erasing anything, my love. I only erased the agreed because I had a non-verbal sort of thing. Okay, so we know what the value of f of x is. Now, what we need to find is f dash of x.
Sure, one moment. I'm kind of in between two glasses right now, but you for the 0 + 1/2, where do you get those values in terms of to get the midpoint?
Remember, I was saying to you before that because I substitute 0 and I got a positive value right here, and I substitute -1 and I got a negative value, it means that my answer lies between 0 and 1. So it lies between 0 and 1. So for my safe bet, I am going to use the midpoint. When I use the midpoint, if I'm supposed to go up, I can go up. If I'm supposed to go down, I can go down. But what I don't want to do is start at 0.7, because I may very well start at 0.7 and my answer is closer to 0.2. Are you following what I'm
Okay.
saying? And if
Oh,
I go to,
sir,
go
so
ahead.
it's kind of like the intuitive approach you're using there to get to know that
Somewhat, but this is what I was trying to explain on Tuesday, that you what you don't want to do is you don't want to hear that an abduction take place in Harvey, but you're going to send the Castleton Police Department to come.
Yeah.
It's a waste of time because that is just way too far.
So just a central point
Right, you
between
want
the
to get
two
to you want to get
numbers.
to you want to get to
Yeah.
close as you possibly can to where it occurred, and then you'll be
Okay.
fine. So you want to get as
Okay.
close to right. So what I'm doing, I'm using the midpoint. The midpoint is the safest bet because you try mute. So using the midpoint is the safest bet that I can go. Either if I have to go down or I have to go up. All right. So we always try to use the midpoint. It's one of the things that you need to be mindful of. All right. Somebody needs some mute. Okay, the person has muted it.
Okay.
All right,
So
cool.
essentially,
Go
sir,
ahead.
you're saying that because I thought this to find x1 is another question. So from this question really started from the function, the original function above,
There you
and you
go.
wanted to find.
There
Oh,
you
so
go.
x1, the subscript there on x1, it can be any number, and then
Absolutely.
we'll iterate through all of those numbers to
Absolutely.
get
Yeah.
the midpoint.
Yeah.
Okay.
So it don't have to be that. Sometimes I give it the first iteration, Sometimes I give it the first iteration, but if I don't give it the iteration, you will have to go ahead and use and derive the iteration. Yeah. But sometimes I give it the iteration.
Okay.
All right, let's go. Because this thing is giving me some issues here. All right, let's go. So we have found our f of x. Now we need to find f dash of x. So f dash of x is going to be equals to, hello? Hello?
Can I ask me to?
Yes, sir.
Cool. All right. Right. So f dash of x is going to be 3x squared minus 8x. Talk truth.
Yes, sir.
No?
Because
Yes,
it's
sir.
the
Yes, sir.
second, the first derivative of the function.
Yes, sir.
All right. Do that for me, please. And tell me what to get. Do that for me. I'll tell me what to get. I'm muting. And when you do that, you'll have the value of f of x, f of a half, and you'll have the value of f dash of a half. Then you're going to substitute that into the equation and then tell me what x2 is going to be. Do that one first, though. Our students, my sincerest apologies. Difficulties. We'll catch up tomorrow. Let me just give you some instructions. I really apologize. From the bottomest part of my heart, I really apologize. Let me tell you what I want you to do. So you got negative 0.325. I wrote something on the last whiteboard. I hope you saw it. So x2 is going to be equals to 0.5, and I'm speaking from memory. 0.5 minus 0.125 divided by negative 3.25. Am I correct right there?
Yes, sir.
Yeah.
Okay, evaluate that for me. When you would have evaluated that, that is going to give you your x2 value. Because I'm giving you homework, and this is a homework. That is going to be your x2 value. Now, you are going to run the iteration one more time. That is going to be x3. So x3 is going to be equals to the x2 value minus f of that x2 value. So you're going to substitute that x2 value in the original function, get that answer out, and then we also substitute that x2 value in your differentiated function, get that value out, and then you do the fraction and the calculations one more time. Am I clear there?
No.
Okay, let me go again.
No, sir.
So you remember what you just did a while ago? We calculated the x1 was 0.5. So we evaluated f of 0.5. Agreed?
Yes, sir.
And we got 0.125. Talk to me.
Yes, sir. Agreed.
Good. And then now we also evaluated f dash of 0.5. Agreed?
Yes, sir. We got
And we
3
got,
point,
no, we
negative
got negative
3.25.
3.25. Very good. So in order to evaluate x2, what we need to do now is to say 0.5 minus 0.125 divided by negative 3.25. Get that?
Yes, sir.
When we do all of that, is when it gives us our x2 value. Now, say, for example, the x2 value works out to be, for example, I don't know what it is. Say, for example, it works out to be 0.65. That means my x2 is going to be 0.65. Agreed?
Correct,
Agreed,
sir.
sir.
Good. So what you're now going to do is find f of 0.65. So we're going to substitute that x2 value into the original function. So you can find f of 0.65. I think that's what I said. And then what you're also going to be doing is substituting that 0.65 into the first differential, f dash of x. Follow me?
Yes,
Yes? No?
sir.
Right. So, and then now you're going to do that calculation again. 0.65 minus f of 0.65 divided by f dash of 0.65, and you're going to calculate your x3 value. When you get your x3 value, you're going to do the process over as many times as you will get the same answer. So when you do it, when you find the x3 now, and after you find x3, say you get 0.65 one more time, it means that you would have completed your calculation because you're going to stop where the values are exactly the same. If you don't get what I'm saying, that's fine. I'll continue tomorrow. I apologize for what I
That's
just
the
said.
root.
That's a root.
Sir,
Yes, yeah, that will be the root.
so essentially you're saying we're going to continue the iteration until we get the same value of the last
Correcto.
one.
Until the answer
Correcto.
starts repeat itself.
Correcto. Until
Okay.
the answer starts repeating, and then you know when you're finished. Correct. Very
All
nice.
right. Sir,
Yes, my
but
love.
whenever they already start, so I
Don't worry
know
about it.
how
Don't
to
don't
move
don't
to the
don't worry about it. Tomorrow is another day. Tomorrow is another day. Hopefully that tomorrow
Okay,
is a better day
sir.
than today. You know, these things happen. You're all computing students. I know these things happen. So tomorrow is another day. I did one quick thing before you guys go. How many of you are very good with C++?
Barely know it, sir.
I barely know it. All right. I must study it here because I'm going to need some help with it. I need to, for open day, I want to set up a robot, but I wrote a program, and I think there's some point of discontinuity. Let me use the mathematics in it. There's some point of discontinuity in the program, and I want an eye to look at it, so it is that I can get my robot up and running. But we can talk about that tomorrow.
Okay.
Thanks, guys. Have a good one.
Yes, sir.
And forgive a teacher later.
Sir, question.
Yes, sir.
Why you say you didn't need help with
C++. You know for the C++ good?
I can do a
Hello?
thing, yes.
You can do a thing. All right. Me and you will link tomorrow. Just remind me tomorrow, yeah? Please.
I say a word.
Easy, puppy. Cool. Later, guys.